cancer survivor. I was diagnosed with adenoid cystic carcinoma 9 years ago in 2010.
I'm an ovarian cancer patient. 2010, I was diagnosed.
I'm 80 years old now, and I'm a prostate cancer survivor.
I'm 29 years old. I was diagnosed with breast cancer in 2015, in February 16th, February 16th, 2015, I was diagnosed with stage 2 breast cancer.
I was first diagnosed with cancer in early 2017.
6年前呢，就发现到Alan 他有癌症的。
我有胃癌第4期。
不管你相不相信都好，癌症不止在马来西亚，在全世界已经变成一个很普遍的疾病。癌症对我的人生的打击很大，因为我的外婆就是癌症去世的。
我当初一知道的时候，我心情一下子就是安静下来，然后我就想，为什么是我？
It was a devastating experience. I felt in total despair, totally lost, didn't know where to go for help.
And when the pathology report came after my mastectomy, my whole world fell apart.
Well, I was quite young when I had my cancer diagnosed. I was really shocked when I actually got to know the news because I've never met anyone my age at that point of time that had cancer.
我不懂我这个做朋友的，我可以帮上什么忙这样子。
I wanted to fight this disease. From there, I decided that yes, there is hope for me, and if I go through this treatment, I will continue to live life.
I had the luxury of going through treatment and having like free medications pumped into me just to reduce all of my side effects. If I speak to patients that have gone through treatment 10 years ago, I noticed that treatments are very different from mine. If it weren't for cancer research, we wouldn't have developed the medications that we have now, the treatments that we have now.
Cancer research is very important because when you have people to find out all this, you can find out what is actual problem with you.
I'm glad that there is this Cancer Research Malaysia, who's always doing research to find cures.
Without research, there's no medical advancement. Like 40 years ago, out of 4 cancer patients, 1 would survive. But because of research, today, out of 2 patients, 1 will survive. So it's thanks to research that less people are suffering. What if 40 years from now, because of your support, because of our support, cancer can be cured?
Join the fight against cancer.
So join the fight against cancer.
Check out Cancer Research Malaysia. Support them. They need all the support that they can get.
Join the fight against cancer and share this video.
You're here, you're loved, you are alive. Rewrite your future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. It's just the darkest, just right before the dawn. Then it's a new day, your chance to take a breath. There's been pain, there's been tears when you said that you can't go on. But have faith and embrace. Now the sun has come. Let it shine and show your path. You're here, you're loved, you are alive. You're not your past, who you are is much stronger than that. But if you future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. A brand new spirit, the time has come to soar. Ooh, there's strength within you, no one can tear it apart. Wipe your tears, don't forget those scars prove you have been through all. So stand tall, spread your wings. You have braved through your pain. Now let your courage take flight. You're here, you're loved, you are alive. You're not your past, who you are is much stronger than that. But if you fall, you get up, fight with all your might. You're here, you're loved, you are alive. Rewrite your future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. I'm here, I'm loved, I am light. I'm not my past, who I am is much stronger than that. But if I fall, I get up and fight with all my might. I'm here, I'm loved, I am light. Rewrite my future, I know that the phoenix will rise. I'm by your side. Everything's gonna be alright.
Good evening, everyone. Welcome to our webinar this evening. We're just about to hit here 8 o'clock or so. My name is Gurpreet, and I will be your host. We will wait just for a couple of minutes as people start trickling in, and then we will begin this webinar here shortly. So feel free to sit back, grab a cup of water. If you need a bio break, this is a great time, and we'll get started in just about 2 minutes or so.
Hi, everyone.
Hey, George, welcome. We are in a 2-minute pause, and we're going to get started here in just a second. Thanks for showing up.
Okay, sorry, I'm having some trouble with that, background thing again. So,
Yeah, no, that's okay. That's all right. We
it's
love
all right,
seeing
right?
the map on the back of your wall there.
Okay, yeah. I'll get used to seeing that map for a while now. It's
Thanks,
my
God.
it's my bucket list map.
Awesome. That's great.
So we're going to do the same thing, right? So, obviously a little bit of active talk. I have 7 talking points. So I'm just going to, go on that. And so what's the time scale that we're playing at today?
Actually, we're just about to start, George. So sorry, I'm going to interrupt you. We'll share the schedule with you separately. Thank you, George. All right, we'll just wait for 1 more minute or so, about 8:02, and we'll get started. Once again, thanks for joining us. Glad that you're here with us this evening. All right, so we've just hit 8:02. Once again, good evening, everyone. Super glad that you're here with us this evening. I was once told a couple of years ago, when we say yes to something, it also means saying no to something else. So we just want to take this time to say thank you for saying yes to being here tonight. We recognize that choosing to be yes, saying yes here and being here actually meant you said no to something else that you could potentially be doing, whether it's hanging out with your kids or being out with your friends on the mama store, having some food, or even having supper. So we wanted to sincerely thank you for your time and your sacrifice. Thank you for joining us. Today, Cancer Research Malaysia, in collaboration with My Starfish Foundation, has worked together to put together this webinar entitled, Your Body Could House the Best Defense Against Cancer, and Vaccines and Immunotherapy Could Supercharge It. Really, our bodies are amazing in the ways that in which it's built, and we're excited to share a lot more about this particular area of our work. But before we do that, we just want to share some housekeeping matters, just so all of us are informed and know what's going to happen here in the next hour and a half or so. So attendees, just so you're aware, you'll only be on listen mode only, so your mics are muted. Also, please note that this webinar is actually being recorded for future viewing. So if you're not comfortable to have your name show up and so on, you can rename yourself just for your own privacy matters. Just so take note of that, we are recording this webinar. And thirdly, we're really happy to hear from you. Part of what we want to do as we launch webinars like this is engage with people that are joining because we want to hear your voice. We think your questions matter. The things that you say are significant, and we want to actually be able to address some of your queries or some of your questions. So just so you know, there's actually a Q&A tab on the bottom of your screen. If you're in Zoom, you can go ahead and click on the Q&A. And at any point during our webinar today, you feel you have a question, you need something addressed, you need some help, go ahead and just write in your question in the Q&A tab. If you're in Facebook Live, you can use the chat feature. I believe it's on the right-hand side of your screen. Go ahead and write your questions. We have actually team members from Cancer Research as well as My Starfish Foundation in their own sort of Facebook platforms who will then translate or take that question and put it here into the webinar feature. So our panelists here today can also address that a little later towards the end of the session where we'll have a Q&A session. So once again, we want to hear from you. Please ask your questions and we'll do our best given the time that we have to address everything that comes to us in that way. And lastly, say after the webinar, at the end of the webinar, maybe you sleep at night and then tomorrow morning you have a question or you have a query or you want something, you want to know more about our work, feel free to always go to our website. That's a great place to start, Cancer Research, www.cancerresearch.my. All right, for those who've joined us, just joined us. I see the numbers are going up, about 116 attendees right now. Once again, thank you for joining. My name is Gurpreet, and I'm actually the engagement manager at Cancer Research Malaysia, and I will be your host today. And in case you didn't know, Cancer Research Malaysia is the only non-profit organization that is focused on saving lives through impactful research in Asians. Now, to share more about our organization and some introductory remarks, allow me to invite Cancer Research Malaysia's Chief Scientific Officer, Datin Paduka Dr. Teo Su Huang, to share a few opening remarks. Datin Paduka is actually an award-winning scientist. She founded Cancer Research Malaysia in 2001, and since then has won numerous awards, including Wellcome Trust Collaborative Science Award and many more. So she was also awarded the Honorary Order of the British Empire by Queen Elizabeth II. Prof. Theo, over to you.
Thank you so much, G, for that very nice introduction as well as the warm welcomes. And really like to echo what you said and to thank everyone for making time and effort in joining us today. And also in particular to really thank our panelists, especially Dr. George Lee and Prof. Ho, who really took time out from their busy schedules and coming straight from their clinics to be able to join us in today's webinar. Next slide, please. So what are we going to talk about today? Well, the reality is, unfortunately, many of us are going to be told these three little words, that you have cancer. And for many people, they're going to be thinking, how much time do I have left? How much will I suffer as a consequence? And increasingly, because of the cost of therapy is getting expensive, how much will it cost? And how much will it cost my family? Where's the money going to come from? And so on and so forth. But imagine that if you are told you have cancer, we believe that cancer has a different outcome. So imagine that instead of believing that cancer is a death sentence or associated with death, you might have an outcome where cancer is curable. So what happens if you have that view that cancer is a curable disease? Then what must we do in order to be able to advance cancer research in order to ensure that we can able to tell more individuals that their cancer is cured? Next slide, please. That's exactly what we're doing in Cancer Research Malaysia and in medical research organizations throughout the world. Next slide, please. And through the research work, we've actually improved treatments. So in 1970, only 1 in 4 patients survived 10 years. Today, 2 in 4 cancer patients survive 10 years. And imagine with the advances in medical research, potentially in the future, 3 in 4 or even more cancer patients will survive at least 10 years. And hopefully we're not going to take another 50 years to get there, but this will happen much sooner through the investments in research. Next slide, please. But the challenge is today, nearly 19 million individuals will be diagnosed with cancer and nearly 10 million individuals will die of the disease. And I think as an Asian, what I find really sad is 49% of the cancer cases occur in Asians and 58% of the deaths due to cancer occur in Asians. So even though we make up half of the world's population, we make up a much more significant proportion of the deaths due to cancer. And this is an atrocity. Next slide. So what are we doing about it? So even though Asians make up 50% of the world's population, we only make up 10% of genomics research. And this has already increased significantly from 2% to about 10%, but it's still very, very far away from the 50% of the world's population. And as we know, without medical research, we can't improve treatment. And if we don't have this research conducted in the Asian population, will we be able to harness all of the advances in medical research to be able to improve survival in Asian patients? Next slide, please. So as mentioned by G, our research is to focus on the Asian population. In many ways, Asians may not be different from the Caucasian population, and the treatments that have been developed in the Caucasian population may also work in the Asian population. But in many cases, we don't know. We simply don't know until we do the research in the Asian population. So let's watch this slide, this video presentation to learn a little bit more about the work that Cancer Research Malaysia is doing.
Welcome to Cancer Research Malaysia, where scientists are on a mission in finding ways to prevent, detect, diagnose, and cure cancer. Our areas of work include cancer genetics, genomics, immunology, translational biology, and clinical trials. Our experiment helps us to find what has gone wrong in cancer cells. We have developed one of the largest collections of oral cancer cell lines derived from our patients. These help us to develop and test new drugs for oral cancer. The use of specialized instruments helps us understand the patient's immune system for the development of cancer vaccines. We have established the largest breast cancer biobank in the region, and we lead on the Asian research of major breast cancer studies. Our scientists are committed to conduct impactful research here in Malaysia, so that the fight against cancer do not miss Asians, especially Malaysians. We are on a mission to reverse the Big C.
As you can see from the very brief introductory video, we have a lot of laboratories that are currently doing research to try and understand better how cancer occurs in the Asian population and how might we use this information to develop better ways of diagnosing, detecting, as well as treating the disease. But three areas in which we're investing, particularly in immunotherapy, we are now using our understanding of the immune cells to be able to use immunotherapy potentially to treat breast cancer patients in Asia in a clinical trial that is led by Professor Ho Kuo Fang, one of the panelists today. Under Prof. Chong Sok Ching's group, together with Dr. Lim Kwei Peng, we've developed an oral cancer vaccine that is now completed preclinical studies. And if everything goes well, we'll be going into first-in-human studies and potentially testing this in terms of improving treatment outcomes for oral and nasopharyngeal cancer patients. And very recently, we've won a research grant from the pharmaceutical company to be able to test a new combination of immunotherapy and chemotherapy together with our partners in University Malaya. And Prof. Chong is one of the co-investigators for this PIPER clinical trial. So what we look forward to doing today is not only sharing with you some of the basic information about our role of the immune system in cancer development, but also to talk about some of the treatment options that are currently under development in Cancer Research Malaysia and what we might be able to do in terms of improving outcomes. So over back to you, G, in terms of taking us through the program.
All right, thank you so much, Prof, for the insightful presentation. As we've all seen, over the many years, there's many significant discoveries and advancements made in the field of cancer research, particularly in Asians. And we believe that cancer can be and will be a controlled disease one day, that only through scientific research, we will find new ways to prevent, to diagnose, to treat, and to manage cancer in a holistic way. And as part of this effort to ensure that we continue to strive forward towards a better tomorrow, towards a future that is free of the fear of cancers, our partner, My Starfish Foundation, has launched Bald and Beautiful. It's a campaign that's run to accelerate the advancement of cancer research, to support cancer patients and their families, and to raise funds for cancer-related NGOs. So let's just have a quick look here at a short video describing more in detail what this campaign is all about.
You're here, you're so that the phoenix will rise above.
Apologies, just some technical issues. Just give us a second. Sorry about that. All right, fantastic. We hope you got some high-level understanding of what Bold and Beautiful 4.0 is all about. Really seeking to continue to advance cancer research, support cancer patients and their family, and fundraise for cancer-related NGOs. And we'll share further detail on how all of us can really come together to add velocity to this particular campaign. Now, I'd like to invite Dr. George to moderate a panel discussion with a number of our panelists exploring how our bodies can actually house the best defenses against cancer and how vaccines and immunotherapy could supercharge it. And now just on our panel, just by means of introduction, we have Professor Dr. Ho Huang, who is the consultant oncologist from University Malaya Medical Center. We have Professor Datin Paduka Dr. Teo Su Huang, who is the Chief Scientific Officer from Cancer Research Malaysia. We also have Professor Dr. Cheong Sok Cheng, Head of Translational Cancer Biology Research Unit at Cancer Research Malaysia. And lastly, we have Dr. Lim Kui Peng, who is the Head of Cancer Immunology and Immunotherapy Unit at Cancer Research Malaysia. George, I'm going to pass it all over to you now, so please take it away.
Gee, thank you so much. I'm so excited. You know, earlier on, you said that if we give up something for this evening, we are really kind of like in return doing something else. I tell you, I'm in a win-win situation at the moment. Do you know what today is? Today is a singles day. A lot of us are actually, going shopping and then online and that sort of things, and apparently clocking up a lot of mileage on the credit cards. But that is a win-win situation for me. I'm not clocking up any mileage tonight. And instead, I probably will clock up some mileage to donate something for Cancer Research Malaysia. Do you think that's a good idea?
That is fantastic. A great way to spend singles night, for sure.
Indeed. And I don't feel so singled anymore because I've got, all these powerful panelists who I worked well with in the last 10 years or so. Suhang, I just want to congratulate you because earlier on when G introduced the Cancer Research Malaysia that was established 10 years ago, I remember about 14 years ago, you, your husband and myself, we decided to come back from Cambridge, and time flies, before we know it, at blink of our eyes, you already set up this most amazing establishment in the last 10 years, and congratulations to you.
Thank you so much, George. George, you're probably the only person that looks younger in person than you do in that photo that we have of you. So it's really nice that we've known each other for more than 30 years, but it's one in which we've been able to partner in so many ways, right? Particularly doing what you do best, which is really breaking it down and helping the public understand more about the technical aspects and breaking it down in a way that hopefully the lay people can also understand and follow us in this journey.
In fact, that's my secret, to be honest with you. I feel like I'm a lay person at the moment. The other win-win situation that I have tonight is that every time we do a webinar like this, I must tell you that all the new technology, all the new researchers, you really laid it out to me so that I can digest it as a mere urologist. I really find that extremely useful. I'm really looking forward to, holding this panel tonight because, for us, we all think about the actual immune system as something of a mystery because is this a good guy or bad guy in us? And tonight, we really want to tell the public that this is our weapon against cancer. And how do we enhance this weapon? So, obviously, Dr. Ho, we've been working together at UMMC those years ago. And obviously, time has changed since I left. And then also, Dr. Cheong, we have had multiple sessions where we interview you on Doctor in the House on BFM and also Dr. Lim as well. So tonight, I'm going to put you on the spot instead of people put Dr. G on the spot most of the time on these naughty subjects. But tonight's the subject is not so naughty. However, we're going to dwell into a lot of very important subjects, right? So are you all ready? So ladies and gentlemen, thank you very much for joining us. I want to highlight this, right? Okay, this immune system, without active immune system, do you think we really will get cancer at some point? Because, I always assume that people who suffer from HIV, for example, we know that they are more prone to susceptibility for Kaposi sarcoma and various cancers. However, what about congenitally? If someone was born with a compromised immune system, will they actually develop cancer before the age of 21? Let's get Professor Ho into the discussion. Professor Ho, what is the facts behind without active immune system? will we get cancer before the age of 21?
Why do I get the difficult question first?
Of course, you know, if everyone put me on the spot from time to time, it's my turn to put someone else on the spot this evening.
We may all have cancers before age 21. I don't think that is true. When you have very impaired immune system, the risk of getting cancer, of course, is a bit higher. Some hematological cancers, for example, but immune system will prevent us from getting some cancers because of phenomenon called immunosurveillance. So so I think immune system is important, but if immune system is impaired, doesn't mean that everybody will get cancer. So I don't think that statement is true.
Okay, I mean, Su Wang, my understanding is that our immune system is a check and balance. It obviously, on one hand, trying to raise our immunity to fight against diseases and various things that can go wrong in our body. But on the other hand, it is also something that can potentially go wrong. So is that true that somebody may develop some sort of cancer at the age of 21 if they have impaired immune system?
I think the point is, if we had no immune system, we probably all would be at a very high risk of developing a whole range of cancers. And that's because cancers arise from our own cells, and our immune system are usually involved in surveilling our own cells to figure out whether there's something that's gone wrong. So if we don't have an ability to be able to detect whether these cells have gone a little bit different and they are on their way to developing cancer, then I think the cancer incidence would increase quite a lot. I think the point of this is to basically drive home the point that our own bodies have an active immune system, and active immune systems are critical in fighting cancers, and invariably there's something that has gone wrong in nearly everyone's immune system when they do develop cancers later on. So differences in the immune system is one of what we call the hallmarks of what goes wrong in cancer cells. Yeah.
Okay, I note that. All right. Okay. I mean, Professor Cheong, the last time we spoke on BFM, we discussed all these translational kind of like data from lab to the actual bedside and also in clinical use. So if I ask you, which part of immune system actually control or prevent us from getting cancer, and sort of what sort of research has been going on in that highlights this particular importance of immune system? Can you share that with the listeners and also the participants out there?
Sure, thanks, George. Good to see you also. And I mean, on your question of which part of the immune system helps us kind of ensures that we don't get cancer, actually the immune system can be divided into two main big parts. One that is kind of reactive. The moment it sees an enemy, it will attack. The other one actually basically helps us build up in memory of the enemy. So actually both parts of the immune system are important for us to fight cancer. And particularly certain subsets of immune cells are particularly important. So for example, what we call the cytotoxic T cells are particularly important because those are the cells that are able to recognize foreign things, and cancer cells in a way, although originating from our own body, is somewhat foreign because it has undergone some form of mutation, and therefore the cytotoxic T cells are able to detect them and then eradicate them. So this is one of the cell type that is particularly important in the immune system.
All right, fantastic. I mean, obviously, we highlighted that immune system is important in cancer control and prevention. However, presumably in the last few decades, we have lots of research specifically identify which immune system should be raised in order to fight cancer, right? I mean, Dr. Lim, perhaps as a head of cancer for immunotherapy, so can you tell us that in the last 2 or 3 decades, what sort of advancement has specifically looked at immunity in cancer prevention?
I think for cancer prevention is currently very actively for the viral-related cancers, because viral-related, so you can target them. So there are relatively quite a number of vaccines being developed to purposely target viral protein. So for those immune cells who are trained, when you see there's a viral protein, we will kill them. So subsequently, you will kill the cancer cells. So this is for preventative therapy for cancers.
Right.
And also, we also got hepatitis B to prevent liver cancers.
Sure. Presumably, the two preventable cancers that we have the weapons against by raising our immunities are Hep B, which a lot of us had during our childhood, and then, continue to do that because in Asia Pacific, we have these horrible problems of hepatoma as a result of hepatitis B, and that probably changed the game plan for us. And obviously, the other thing that you mentioned, it's viral prevention of human papilloma virus that causes cervical cancer, and then that is an ongoing thing. But obviously, that's on prevention basis. However, looking at this particular statement, without active immunity, we all may develop cancer. So were there any sort of specific study to look at how we can use this particular information in order to enhance our immunity so that it can use for treatment rather than for prevention?
No, that's $1 billion question, Dr. George. I think anyone who is in this space would love to be able to create a potion that somehow boosts our immune system so that none of us could get cancer, right? So it's $1 billion industry. And I think the reality is that there are a lot of things that have been shown to boost the immune system, but none have been shown to be specific enough to sufficiently reduce or eradicate cancers wholesale, right? There's nothing that we can eat or drink or probiotics or anything like that, any sort of supplements that we can take that unfortunately will be able to, eradicate cancers and prevent them from happening altogether. But I think what is promising is really how do we harness the power of the checks and balances of the immune system to be able to reactivate the immune system in ways that enables us to fight cancers more effectively. And perhaps that's the space that we should really be talking about. How is it that cancers evade the immune system? And maybe that's the second point that we're going to move on to.
That's right. The second point is cancers have invisibility, cloaks that can help cancers evade immune system. So is that true? Come on, let's get the panelists discussing this. I mean, Dr. Ho, again, I would actually, why not? We let the ladies go first. Prof. Cheong, what do you think about this statement? Can we have the next slide, please?
Yeah, this is something that I think we're beginning to understand more and more how cancers tend to be able to evade the immune system. And by understanding this, we're able to actually unveil the cancers so that the immune system can see them better and not only see them, but see them as enemies in order to attack them accordingly. So there are immunotherapies that are being developed now in order to be able to unveil the cancers. And I will let the other panel members comment more about that.
It sounds like Harry Potter, George. Invisibility cloak sounds exactly like Harry Potter. And this is exactly why we called our clinical trial with Prof. Ho Aura, or AUROR, because we've been dealing with immunotherapy for breast cancers, looking at how it is that we can unveil the invisibility cloaks.
So if the cancer is the Harry Potter is trying to evade us, right? What about oncologists? Dr. Ho, who are you in the era of Harry Potter? So if you try to catch Harry Potter, how do you do that? If cancers have that amazing ability to have that magic, how do you solve that problem?
Yeah, so we are the auras. So the good thing about doing clinical trial is that you can name them. And that's the biggest fun of running a trial. So we name the trial oral. So the thing about the tumor is that now they know that tumor can have this cloak, which is called programmed death ligand 1. So what it does, it turns off the immune cells. So we may have the immune cells that can attack the tumor cells. But when tumor expresses this PD-L1, it switches off the immune cells. Therefore, if we can block PD-L1, then you can activate the immune cells. That's how it works.
Right. Is it as simple as that, or the whole picture is a lot more complicated?
Of course, it's very complicated. That's kind of simplest form, yeah.
It's the simplest form, right?
If only life was so simple, right, George? You know, we would like to, you know, think of cancers as a simple mechanism that we can explain. But as we learn more about human biology, we're always amazed by the complexity of the immune system and how immune cells can evade how cancer cells can evade the immune system can happen through many different mechanisms.
Yeah. So is this nature or nurture? Is it because we intrinsically have this genetic code that's gone wrong that actually make us more prone to cancer, that the cancer has developed all these ability? Or is it because all the nasty things we do to ourselves that makes us having that susceptibility?
Yeah.
I think part of the reason is because cancer is a chronic disease. So when the cancer cells has been living with an individual for quite a long time, it started to fool your immune system. For example, you can't think of your friend of 5 years as your enemy. So the same thing that the cancer cells trying to fool your immune system. Hello, I've been your friends for 5 years. You still see me as enemy. So that's how they put up the invisible clothes to ask immune cells not to attack them.
Wow, that's well said. You know, it is really good. But obviously, if you are not really looking after yourself, for example, you smoke, you drink a lot of alcohol, you put yourself through stress, and that itself is putting an impact and suppression on your immunity, and that makes the cancer more susceptible. Is that the simplest way of looking at it, Suwan?
I wish that was true, but unfortunately, I'm not sure it actually works that way. So when you are exposed to a lot of carcinogens, like from the cigarette smoke or from sunlight and UV light and so on, and you know, the alcohol and other things that we enjoy in our diets, red meat and barbecue meat, etc. The idea here is that, you know, maybe all of these carcinogens can damage the DNA, and damaging the DNA in a sense makes those cells different from normal cells. So you would have thought that if cells are different from normal cells, the immune cells would come along and get rid of them, right? But actually what we've found is that the cancers that are driven by these external mutagens or external factors tend to develop a PD-1 checkpoint in order to be able to evade the immune system. So in other words, our immune systems are very actively involving in getting rid of these cells that have become abnormal, but the ones that are driven by this abnormality, you know, when they develop, they have that invisibility cloak. So ironically, the cancers that are driven by these external carcinogens are more likely to respond to the therapy that Prof. Ho talked about, the PD-1 checkpoint therapy and so on, right? It's a funny way in which life works.
Right, okay. So I guess that will take us to the next fact, really. So if we can have the next slide, the next fact said there are 5 types of immunotherapy approved for more than 20 types of cancer. So this is a part I'm more fascinated. I'm sure a lot of participants out there are fascinated. We're really clearly boggled by all these different types of cancer. We're even more boggled by what sort of things are more immunotherapy, what sort of things are more susceptible to chemotherapy, for example. I'm confused. Can someone help me? I mean, So Chin, perhaps you can just identify a little bit about what sort of cancers are, immunotherapy are working and why, and then perhaps then later on, Kui Peng can tell us a little bit about what sort of immunotherapy is available.
Sure. I think basically when we talk about immunotherapy, we're really talking about many types of immunotherapy. Just like when we're talking about chemotherapy, it's not really one drug, right? I mean, chemotherapy refers really to basically treating patients with many kinds of drugs. And the many kinds of drugs basically depends on the cancer that you are actually treating the patient for. So for immunotherapy, again, it's several types of therapies. It's not just one. So when you hear people talking about immunotherapy, don't just think of one. I think that's the point of this fact. There is not just one single therapy. And immunotherapy currently in the form of at least what we called the anti-PD-1, for example, has been approved for many types of cancers, about 20 types of cancers. So for example, it was first approved for a type of skin cancer called melanoma, but subsequently it has now been approved for lung, bladder, head and neck cancer, and many types of cancers. And when we talk about the types of immunotherapy, they kind of funnel into one main point. And the main point is, how do we activate the cancer killing ability or enhance this cancer seeking and killing ability of the immune system? And we can do that in various ways. And maybe I will pass the baton to Dr. Lim to tell us about the various different ways. Yeah.
I think I will name a few. What Dr. Chong was just saying was anti-PD-1. So anti-PD-1 basically is trying to remove the invisible cloth that we just mentioned in the previous questions. But bear in mind that even though after we remove the invisible cloth, you can see your cancer cells. So the next thing would happen is you need somebody who can kill the cancer cells. So the agent that can kill cancer cells we call immune cells or cytotoxic T cells. So theoretically, the second type of immunotherapy is if the patient can't make enough T cells or can't make enough policemen to kill the cancer cells, then we can exogenously or externally transfer more T cells into the patients, called a CAR adoptive cells transfer therapy. So give them more immune cells so that they can kill cancer cells. A second type of immunotherapy will be slightly different from the first type. First type is directly importing immune cells to kill cancer cells. Second type is you already have some immune cells. What I need to do is I just want to make the immune cells stronger. So I will do immune modulation. I give them some immune modulation drug to boost up your immune responses. And the last but not least is if you do not have good immune cells and you don't want to take it from adoptive cell transfer, we can start training on immune cells using a vaccine. So we have a vaccine to train your immune cells and tell them, hello, remember, this is cancer cells. So next time when you see them, you will be able to kill them. So these are the three major immunotherapy that trying to enhance the killing ability. But at the same time, we have other immune cells as well. That's why we also have antibody-based immunotherapy to try to have more neutralization and killing of the cancer cells. And last but not least, also in a very active research, we have oncolytic virus therapy. So we are carrying the virus into the cancer cells and ask the virus to start to lyse the cancer cells and trigger a whole plethora of immune responses. So these are some of the major immunotherapy that's currently available in the market.
So Wang, I told you every time I listen to this, I learn a lot of things and it consolidates my mind. So,
but George, as a urologist, you are one of the first specialties to use immunotherapy in the treatment of cancers, right?
That's right. That's right. So that's why I am really fascinated, because I assume that, for example, bladder cancer, we use immunotherapy in order to enhance your body immune system in order to suppress that cancer. So I'm going to ask, Dr. Ho, to put him on the spot. Clearly, Kuiping consolidated to say that if your immune system is not so good, we transfer immune cells into you. So can you give some example, what sort of like immunotherapy you offer the patients, and then what sort of cancer and what sort of response rate they get for that sort of like, modality?
So the one that Dr. Lim said, adoptive T cell transfer, is basically you manufacture more T cells and then you transfer it from maybe a donor to the recipient. Actually, we did a study on it with our collaborators from National Cancer Center Singapore a few years ago. So they transferred the T cells, actually patients on T cells against nasopharyngeal carcinoma, nose cancer. So they take out the T cells that can attack the nose cancer, culture it, and then give it back. So it's called BAN study. Some patients achieve long-term remission. So you can use more T cells to help the patient fight the cancer. So that is adoptive T cell transfer. Of course, now the most common one is the PD-1 inhibitor or PD-L1 inhibitor. That one is like pembrolizumab. I cannot mention drugs name, or nivolumab, this kind of drugs. So as oncologists talk about drug names. So that one is the one that activates the immune cells so they can attack the cancer cells. The CAR T cells, that one is currently mainly used by hematologists because CAR T cells, basically you have to engineer the T cell so that it attacks certain tumor cells. So they have to select certain characteristics of the tumor cells so that you can engineer your T cells to attack it. The thing about solid tumor is they are a bit more heterogeneous. So there are all kinds of different tumors inside the big tumor mass. So it's very hard to design a CAR T cell that can attack all the different types of tumor inside the body. So CAR T cell currently mainly for hematological cancer. Oncolytic virus, my big boss, Professor Harrington at Royal Marsden Hospital was actually researching on it 20 years ago. So now I think they have a bit more success, but it is not really for prime time use yet. So we hope to see more oncolytic virus in the future. But when you talk about the cancer vaccine like BCG, which we use for TB, now we use it to prevent the bladder cancer recurrence. That one is a kind of cancer vaccine. Yeah.
Okay. I mean, you gave the impression that a lot of these are not in, mainstream treatment yet. Is that true? I mean, I just want to gauge a little bit of a flavor of how many proportions of your patient, let's say, receive immunotherapy in the mainstream. For example, nasopharyngeal cancer is so common in Malaysia. How often do you offer your patients immunotherapy?
Nasopharyngeal carcinoma, we did a study on it actually with pembrolizumab. The result has been announced, so I can talk about it. Response rate is 22%. So some patients do respond. So people respond as well to immunotherapy as to chemotherapy, but did not result in better survival compared to standard chemotherapy. So in real life, we don't use it that much, mainly because of the cost constraint. So in terms of side effect, of course, there's less side effect with immunotherapy compared to chemo. So if you say head and neck cancer, it is established, it is licensed, so we can use it for oral cancer, tongue cancer, throat cancer, those kind of things is already licensed and can be used. But if you talk about in real life, maybe about 5% of patients using it because of the cost constraint.
So Wang, I know Cancer Research Malaysia is renowned for making a lot of frontiers, kind of like a discovery as far as focusing on Asian populations. Right, can you please highlight a little bit of what sort of research are you guys doing in relation to immunotherapy and specifically focusing on Asian population?
So I think the type of immunotherapy that we're working on, like you hear from Prof. Ho, that you've got the cell-based therapies like the CAR therapies and so on, and then you've got the adoptive T-cell therapies, etc. Whereas what we're really talking about is for pembrolizumab and checkpoint inhibitors, the PD-1 and PD-L1 inhibitors and so on, they seem to be really promising for a few cancers, like for lung cancers, head and neck cancers, even kind of bladder cancers and the MSI high cancers across the board and so on, right? They seem to be really promising, but the challenge is that only a small proportion of the patients with that specific cancer seems to respond to the immunotherapy, and we know very little about why is it that some respond but others don't. And when a therapy is so expensive, we really need to make sure that we can target it to the people that are more likely to benefit, and hopefully that will improve the outcome for those individuals, while trying to understand why is it that the other individuals don't benefit, and what we might need to do to be able to improve outcomes for those individuals. So a lot of the research that's been led by Prof. Cheong and Prof. Lim have been focused on has been really on how do you improve more responders, how do you get more people to respond to these checkpoint inhibitors. And the strategies that are being employed now are to try and figure out how do we increase the number of immune cells that are within the tumor environment, potentially using a vaccination strategy. So the way we think about vaccines is usually in a preventative setting, right? But what Kui Peng and Sok Ching and team are doing are really talking about therapeutic vaccines. How do we use something external to be able to boost the immune system to be able to fight the cancers more effectively once the cancers have already developed, rather than preventing it from happening?
I guess that conveniently takes us to the next fact, really, isn't it? Let's go for fact number 4. Vaccine can help to prevent cancer, but they can also help people with cancers. I mean, I highlighted earlier on that at the moment, we're doing extremely well with hepatitis B. And that's one of the few cancers that is preventable by mass vaccinations. And we're trying so hard to get 12 to 13-year-old girls vaccinated with as many strains of human papillomavirus as possible, and also try to prevent the boys from getting the genital warts and oral cancers and anal cancer and these nasty things. And we know those are preventive, but can vaccine actually be used for treatment? I mean, I find that quite extraordinary. I mean, Prof. Cheong, can you elaborate that a little bit?
Yeah, sure. So, I mean, if we understand how vaccines work, I mean, even in the infectious disease setting, right, the first thing we need to identify is what we call an antigen, or the protein belonging to the enemy, right? In an infectious case, basically a part of the virus or a part of whatever is causing you that infection. So, for example, I mean, people now are very well versed with vaccines because of the COVID-19 pandemic. We know that vaccines made for the pandemic was actually through a particular protein called the spike protein of the virus. So once we identify a unique antigen that's causing the disease, we are able to create a vaccine. So in a very similar context, that is exactly what we can do in order to create a therapeutic vaccine for people who already have cancer. So that brings us to, for example, the work that we do in Cancer Research Malaysia is to identify for head and neck cancers, what is the unique antigen or protein that we can identify on the cancer cell that is not present in the normal cell, because when you vaccinate the patient, you want the immune cells to be sensitized or aroused by this particular vaccine, and then go and hunt out the cancer cells. So if we can find this unique protein, the immune cells will only attack the cancer cells and then leave the normal cells unharmed. So that's the kind of concept of creating a vaccine for therapeutic use or for use in patients who already have the cancer.
I mean, Dr. Lim, would you like to elaborate a little bit?
Yeah, I think just to continue from Sok Cheng, so after you find out the protein that are uniquely expressed in cancer cells but hardly seen in normal cells, the next thing you have to make sure is your protein is very, very important. So after you train your immune cells to target cells that express your specific protein, if your protein is not important in the functions of a cancer cells, so cancer cells will be very smart and say, this protein, now people are killing you, you better stop expression so that I won't get killed anymore. So in the evolutions of the development of cancers, if your protein are not important in the living or in the cancer carcinogenesis, the protein will get suppressed. So subsequently, after we found the protein, we have to make sure that this protein play a major role in the cancer development of that particular cancer type. So that's how we identify our two major proteins that they're not only overexpressed in cancers, don't express in normal, but they play a major role in the carcinogenesis of oral cancers and nasopharyngeal cancers.
Wonderful. I mean, Professor Ho, when I think of vaccine, most people think of vaccine just like a COVID vaccine. You get injections and then you get some sort of protection, and there's a finite number of injections you get. So obviously, it's the same concept of prevention for hepatitis B and also for HPV vaccine. When we talk about receiving vaccine as treatment against, head and neck cancers, how does it work? I mean, how many vaccines do you get, and how often do you have to get it? And what sort of side effects do you get when you receive these sort of vaccines in a clinical setting?
Yeah, actually, cancer vaccine, using vaccine to treat cancer, it's not in prime time use yet. It is not easy to make a vaccine that works well to activate immune cells to attack the cancer. So far, all the vaccines that work are vaccines against virus, like HPV or HBV, so that the patient does not get the virus infection and does not get the cancer. So if the patient already has a cancer, Dr. Lim and Prof. Cheong described just now, you need to find out a way to activate the immune cells to so that you activate immune cells to recognize the tumor cells. And so far, in the past 30 years, majority of the cancer vaccine trials have failed. It's not so easy to vaccinate the patient so that they can attack the tumor. It is, in fact, very difficult. But I think the peptide vaccine that Prof. Chong is developing is promising, i.e. if the tumor has unique characteristic and you can activate the immune cells, then it is possible. Of course, this is also subject to the tumor continue to express the protein. If the tumor changes the expression, then the vaccine will not work so well. But BCG is one of the most effective vaccines so far because somehow you activate the immune cells to attack the bladder cancer. So yeah, so that's a very successful.
I can tell you, I use BCG a lot for bladder cancer. It's a very dirty drug. When you put in there, the immune system sometimes can go haywire, and the patient have different sets of problems after receiving BCG. So that's another problem. Is that right, Suwang? I mean, sometimes we can overdrive these kind of immunity, and sometimes patients get different set of problems altogether.
Yeah, I think clinicians like yourself and Prof. Ho will be much more familiar with managing side effects in patients and the unwanted consequences of therapy, right? Which is why I think the therapies of the today and tomorrow is more about how do you increase the targeted specificity, the outcome that you want without all of the side effects. And to be able to do that, you cannot use such a crude vaccine like BCG because it's got a lot of the other side effects. You know, basically you're putting in and overstimulating the immune system in ways that you cannot control all of it. You're activating not just the cytolytic T cells, you're also activating some of the B cells, you're activating some of the other cells within that, and that complexity results in a lot of the unwanted side effects. I think, you know, when you start to take on a lot more precise therapies, such as if you're able to actually isolate the specific T cells and only enhance those specific T cells that target cancers, then hopefully the pipe dream is to be able to stimulate the immune system in targeted ways that can kill cancers without giving us a lot of the dirty side effects that may come about with mixed therapies.
I mean, I like the way you mentioned all that targeted, focus, and basically eventually trying to come up with a tailor-made bespoke treatment for cancer patients. Really, this is a dream, right? Eventually, I mean, this is a place that I think it's important for those people. There are 165 of us actually logging in tonight on this singles night. How do you think the general public can help in order to, help you so that we can achieve that dreams? I mean, can you just tell us a little bit on how, if we donate and that money can actually be helped in order to push forward the frontier of science, and also perhaps one day we might find a vaccine that can actually cure, or at least without failure, like many trials has been through.
Yeah, I think, George, you're pointing out a really important fact, right? The whole point is that the way we got to where we are is through medical research. And the only way that I know on how we can improve treatments, develop things that are affordable, effective, and appropriate for our own populations is to invest in more medical research. Now, I think that's the space that we are trying to occupy, and making sure that the research includes Asians, that the research includes development of new therapies that hopefully will be more targeted with less side effects, and hopefully in a ways that can be affordable to more people in the future. I think we have to, it's a big challenge. It's a very tall order. You can see all my white hair from all of this work, but that's the harsh reality. It's a baby steps along the way. And it's by making sure that we can bring the public along with us in this journey and have partnerships such as Bold and Beautiful that raise funds for us, that hopefully continues this effort well into the future. But it's also with oncologists like Prof. Ho, right? I mean, we've been doing a lot of work with Prof. Ho, Prof. Wan Zamania, and others to try and really push the frontiers of clinical trials so that we can take forward more investigations that help us understand the immune system in new ways that we may be able to treat cancers more effectively.
Yeah, I mean, one of the things that I also think is important is for participants to involve in programs like this when you understand, or at least have a grasp of what is happening on the ground as far as research is concerned, immunotherapy is concerned. Then you have that interest, and then you actually will be more involved in such donation and also involvement in help, in the research. Yeah.
But I think the donating public also needs to see where their money is going. So I think it's really nice that, a lot of the money that was raised from Bold and Beautiful has gone into the oral clinical trial, which is what Prof. Ho is leading, right? He's the principal investigator for the oral clinical trial. And that's exactly what we're going to be talking about in the next slide. How it is that immunotherapy may not work for every patient, but it may work for specific patients. And it's critical that we understand more about which patients may respond and what is it that we can do to target immunotherapy to the patients that may respond better.
Okay, I think we have one slide before this. It's about cancer can exhaust immune cells and the checkpoint inhibitors can wake them up. Perhaps we can delve into a little bit, Prof. Ho?
Yeah, so this is what we talk about. Actually, the thing is that because cancer actually have defense mechanism, they try to not to die. So they use the inbuilt defense of our body. Why our body has PD-1? Because you cannot have inflammation all the time. Let's say you have flu now, you have fever, all the immune system is activated. But once you kill off all the flu virus, you want to get rid of your immune cells. So that's why your body has a check and balance. So your body uses PD-1 so that all the immune cells after inflammation will be killed off. So that's why body has a check and balance, and it will kill off the immune cells when they are not required. So tumor hijack this. So they hijack this so that they use it to protect themselves, to tell the body that we are important, so don't kill us. The thing is, because not everybody responds to this kind of checkpoint inhibitor, the usual response rate around 15-20%. That means it is very hard for us to make this drug work, and it is a hit and miss thing. You can check PD-L1 or check other markers, but there is not very good biomarkers that can tell us why checkpoint inhibitor, which is pembrolizumab or nivolumab or durvalumab, will work for certain patients and why it will not work. So the patient selection becomes the key. And now people are trying to, the next generation of studies are trying to identify who will respond better and who will not respond. There's another study which is to stimulate those who are not responding to respond. That is also very interesting, like things like STING inhibitor and things like that. So patient selection and stimulate more people to respond to immunotherapy.
Yeah. Dr. Lim, in your practice, what about in the kind of research labs? What is your your elaborations on cancer can exhaust immune system and the checkpoint inhibitors can wake them up?
I think cancer can exhaust immune system. It's just like what we described before. I think cancers try to fool the immune system so that they can be recognized animal. And how it exhausts the immune system is just like Prof. Ho described, is by activating something called the brake of the immune system, the checkpoint protein. So just same as your car, if you have the brake on, your car can't move. If you have the brake on your immune system won't move. So what we have to do is just give an antibody to bind to your brake or the checkpoint protein to stop it from activating, so that the whole immunity cycle can be activated and all your T cells, B cells can flow into your cancer site and kill your cancer cells.
Okay. I mean, when you talk about cars like that, everything becomes much clearer to me. I mean, can we have the next point? Because I've got 10 minutes left in order to get the panelists get involved. I want you to get involved. For those participants out there, perhaps you start sending in your questions now, because we really want to try our best to answer all your questions about immunotherapy, about cancer, and about research work, right? The next slide is on biomarkers can help to select which type of patient can respond to immunotherapy. This is exactly what Professor Ho highlighted earlier on, that the whole idea is identify who will benefit from it and who will not waste money on these treatment that may not derive any benefit. I mean, Suwang, how do we do that? What sort of biomarkers available for us to identify who will benefit from these?
Great question, George. For breast cancer, for example, you have a genetic marker like the HER2. And when you have HER2, you really need a HER2 targeted therapy, right? That's really a complete match. And when you have BCR able, you have BCR able targeted therapy in some types of leukemia and so on. So you would have thought that PD-1 therapy that targets the immune checkpoints, if you now measure patients that have PD-1 or PD-L1, there would be a direct correlation between these two. Unfortunately, life doesn't work like that. So for reasons that we still don't know, we don't fully understand why is it that even though the therapy was targeting a PD-1 checkpoint, but not all patients with the PD-1 protein seem to respond to this therapy. So there's a lot more complexity within the controls of the immune system because of this checkpoint. And we really need a lot more research to try and figure out how do we pick out patients that will respond better to therapy, and how, by understanding why they respond to therapy, can we develop better therapies for the people who do not respond to therapy today. So what we know today in terms of how to predict patients that will respond to therapy are three things. Number one, if they have a lot of mutations, that's a lot of changes within their genetic content, they're more likely to respond to this type of therapy. That's number one. Number two, if there is more dependence on the PD-1 axis for some cancers, but not for others, they're more likely as well to respond to this therapy. And I think those two are currently probably the more important features that we will look at in terms of at least response to checkpoint immunotherapy. But we have discovered in our research labs, there's not only these that are important. So we discovered that there's a genetic element, a genetic variant that is present in 60% of the Asian population and only 15% of the Caucasian population that's associated with cancers that have a lot of mutations. So buoyed by this hypothesis, we were able to put up a proposal where we could test this hypothesis in the clinic, and that is exactly what we're doing in the AURA clinical trial. So we'll be able to look to see whether, because of this common germline variant that's present in so many Asian breast cancer patients, maybe they will respond to therapy that Caucasian patients will not respond to.
Oh, Dr. Ho, what about in kind of like clinical fronts? I mean, can you elaborate this a little bit?
I think Prof. Teo was a bit modest with her description. So actually, because the research world is dominated by the Western countries, so not many people are interested in us, basically. So if we don't do our own research, we will not get much data for our own patients. So Prof. Teo's group has found that these Malaysians, or most of Asians, have a lot of mutation called ApoB3B. So ApoB3B mutation will make the patients more sensitive, or make the tumor more to have more mutations. Therefore, it is probably easier for the immune system to recognize this kind of tumor. So, and this ApoB3B mutation is quite rare in the West. So that's why we managed to put up, actually, Prof. Teo managed to put up this proposal to MSD, and they are so interested, they gave us the grant and the drugs to try. Actually, in real life, I found that some patients do respond very well. Not everybody still, but the response rate is actually pretty good. We are now halfway through, so it's having interim analysis. So there's a patient with lots of disease on the chest wall. After we gave her pembrolizumab, and then she just responded very well. Now she's still on it after almost over a year already. So we have good responders. So whether this idea will be successful or not, of course, we'll see that. But this is a biomarker that nobody was interested before. So Prof. Teo's group, using all the donated money, has managed to find. Yeah.
Okay. Professor Chong, would you like to elaborate a little bit as well?
Sure. I think just to echo what Prof. Ho has said, I think it's really important for us to be able to set up these kind of cohorts of our own patients. And in order to do that, it really is about collaboration. For example, collaboration between Cancer Research Malaysia, the group of scientists with clinicians such as those in UMMC and also in Subang Jaya Medical Center. And only with these kind of collaborations, we can work together to better understand our patients, collect the samples, do the research. Then following that, with the research, go back to the clinic and ask those clinical questions. And with those clinical questions, do the clinical trials. And as we are doing the clinical trials now with AURA, we're really again having to collect specimens so that we can go back again to the lab to be able to understand why patients respond better, and those we expect to respond, why are they not responding. So that collaboration and working together and also the support from the patients and the carers are really, really very important.
That's why you are the head of translational, cancer service, because at the end of the day, what it means is that taking that knowledge from the bench and then take it to the bedside, right? Eventually, that's what it boils down to, right?
Yeah.
George, this is a terribly scary process because the honest truth is we are trained as scientists and we're very happy to do the research in the laboratory, but to kind of take forward a discovery and propose a hypothesis and then go and make sure that we can test it in the clinic with real life patients with a hope and an aspiration that that improves their survival. I mean, seriously, that's kind of scary business, right? There's a reason why I didn't become a doctor, and you all are doctors, but I'm not. But the reality is because we're working in partnership, because we're enabled by charitable funds such as Bold and Beautiful, we are able to take forward this type of research. And I think only by taking these brave steps towards doing this type of research, we can really put Asians on the map and make sure that therapies are tested in Asians for biomarkers which are specific to the Asian population. And taking these baby steps will really help us advance medical research in the Asian population.
And of course, the most important person in this whole cycle actually is the patient themselves and the people who put their life forwards to the trials and everything, and they put the trust on yourself and for Prof. Ho in order to, to make the understanding of science and cancer treatment a little bit more clearer. We have got about 5 minutes left. I'm going to actually go down to the final fact about some bacteria living inside us could make immunotherapy more effective. I mean, KP, I really would like to hear your view because, is it true that bacteria living inside us to make immunotherapy more effective?
Studies started to show some of the report. The answer is yes. So you have good bacteria and bad bacteria. So in a lot of clinical trials, we started to collect stool samples to study whether microbiome actually does have any effect on the response. So we do see that patients who consistently responded to immunotherapy has a specific type of microbiome versus those that do not respond. And in animal model, when we actually transferred the microbiome from a responded animal to the non-responded animal, we do then rescue the animal to become responsive to the immunotherapy. So microbiome does play a major role, and it's in active research. And Prof. Teo will be able to tell you more because the team is currently actively looking at microbiome for the breast cancer.
So good bacteria, bad bacteria. Prof. Teo, would you like to tell us more?
Well, I think there's very fascinating experiments that have been conducted, and what they were able to show is that at least in the colorectal cancer setting, some patients that have certain microbiome were more likely to respond to immunotherapy than other patients. But for many cancers, such as for breast cancer, this is actually a very, very big question mark. So because we have a very large genomic database in Asian patients, and we already know that the microbiome in Asian patients are different from the microbiome in Caucasian patients. Hopefully we can watch this space, see what we do here, and we'll be able to come back and report on whether the microbiome in the Asian population in a breast cancer setting may be associated with treatment outcomes.
So Chin, I'm going to put you on the spot. I'm sure you get asked this all the time as translational cancer head, right? Okay. Is there any role in kind of probiotics in order to enhance your good bacteria in cancer prevention? Is there any truth in that?
I think that is a difficult question to answer because we don't know the answer to that yet, but we will soon know. I think there are actually a lot of studies now going on, as Sue has mentioned, and people are really have identified, which are the bacteria that has been associated with better response to immunotherapy. So if a group of patients who have been treated with immunotherapy and the ones that are responsive tend to have some enrichment in certain types of bacteria, and that hypothesis is now being tested by packaging these probiotics, so to speak, for cancer patients. And these trials are actually ongoing, and we should really watch this very exciting space.
Okay, all right. I mean, we got about one or two questions left, and then I see that people start texting in their messages and also their questions. We're really looking forward to answering those questions, right? So what we're going to do is to get you all to wrap up our panelist discussion about your thought, your take-home message, right? I started with Professor Ho as a person who on this panelist. I would like you to share with us what is your take-home message for the listeners and also participants out there as far as immunotherapy could be the most promising way to control cancer. So if you can have like 2 minutes to convince people this point, and also what is your take-home message, and then followed by the other panelists, please.
There's no doubt immunotherapy will be one of the most important methods to control cancer in the next 10, 20, 30 years. There's no doubt about it. The response is so good, the side effect is so little. The difficulty now is how to make more people to respond to immunotherapy. So, but I'm sure this will, we have more breakthrough in the future. And also we can select patients better so that they respond to immunotherapy.
Dr. Lim, your thoughts, for the take-home messages for the participants tonight?
I think we can start thinking of changing a paradigm of cancer treatment from getting surgery, chemo, and radio, and now by using our own immune system to fight against cancer. So scientists everywhere, including in Cancer Research Malaysia, is trying to find ways that we can boost your immune system to fight against cancer. So watch out. I think, agree with Prof. Ho, we are going to change the whole paradigm. Immunotherapy very likely to be a mainstream treatment in the whole world.
Okay. So Chin, your thoughts?
Yeah, I mean, echoing what the two panelists have already said, but to underscore the fact that different cancers are different. So a biomarker that is important for breast cancer or colorectal cancer may not be a biomarker, for example, for head and neck cancer or even liver cancer. And therefore, and also in terms of the different populations, Asians and Caucasians in terms of their genetic background. So we really need to invest in research, and the research has to be done on our population so that we can better benefit our patients here.
Okay, Su Wang, last and but not the least, obviously you'll focus a lot more on Asian on the basis that we are not Caucasians, and then we need different research because our body is very different, our genetic makeup is very different. What's your final thoughts on immunotherapy could be the most promising way to control cancer?
Absolutely believe that this is going to be the way of the future, but I think a word of caution that we're not there yet. And there's a lot of overpromise today, and there are a lot of people trying to sell immunotherapy for this, that, and the other. Actually, most of it is overpromise and overclaim, and which is why I really very fervently believe that it's very critical at this point to invest in research, because research will give us the hard data that we need so that we're not selling false hope to patients. While we say it's the most promising thing, it's not yet there. There's a lot more that we need to do. And to ensure that we are not duped, we're not sold the wrong things, and that we're not over-promised things that don't work, it's really critical that we invest in a lot more research.
I totally agree with all of you. So this is a part where I'm just going to run through all those questions. For those of you who are participating, please send in your question, as many as possible, because this is the most precious moment that we get the panelists to answer all those questions, yeah? So, I mean, first question is from Mr. Gesan. I mean, presumably, I'm going to, direct this to Professor Ho. Gesan said, I'm a testicular cancer survivor, 55-year-old, and then also 4 cycle of chemotherapy, which ended in December 2020. Something that strikes me a little bit strange is that he's 55 and also have testicular cancer, which is extremely unusual. Is there any connection to hereditary issues or lifestyle? Would you like to take that?
I think you should take it, isn't it? You are the urologist.
Yeah. I do see quite a lot of patients in this sort of things. And then I must say that testicular cancer doesn't tend to have any hereditary connections. And then there is issues with undescended testicle that actually warm up the testicle, especially if it's not brought down early enough. the risk of cancer increase quite significantly. So I don't think there's any issues with lifestyle or hereditary. And in fact, strangely enough, if you just Google testicular cancer, you see quite a lot of sportsmen, young, fit people who tend to get that. Strange thing is that for Mr. Gesan, you got it at age of 55, which is exceedingly unusual because the vast majority of people who I treat are way below 40. And therefore, hopefully, after the chemotherapy that ended in 2020, someone like Dr. Ho will make sure that you're cured, because we all know that in the month of November, we focus a lot on men's health, and testicular cancer is one of the highlight that we have, because this is one of the most curable cancers on earth. So, Professor Ho, do you agree with me about the curative possibility of testicular cancers?
That's true, but testicular cancer also has two types, the easily curable one and the difficult to cure one. So we have to differentiate the two types also. Yeah.
Indeed, indeed. So let's go through that. Prachat said, will you be sharing the recording to all of us? Hopefully, Gurpreet will answer that question. And then, at some point, I'm sure this will end up in the social media for the Cancer Research Malaysia. Engbo Sunny Fu said that globally, cancer is top 10 million. Is that true, Suwan?
What does that mean, top 10 million? So if 10 million people die of cancer every year, that is absolutely true. And this number is set to increase. So today, about 70% of the deaths due to cancer occur in low and middle income countries. By 2030, 80% of the deaths due to cancer are going to happen in low and middle income countries. So this is really something that, as a Asian country that's still middle income, we could kind of really focus on how is it that we make to ensure that we have better cancer control and better ways of curing cancers that's in a way that's affordable to the wider population. George, there's a heck of a lot of questions that are coming in through the Q&A.
Do you want to help me as well? Okay, Cheryl, any immunotherapy for children brain cancer? Okay, let's get Professor Cheong to answer that.
I think Dr. Lim is typing an answer. Maybe we can direct that question to her.
Okay, Ping.
So basically, yes. So basically, I think in the very beginning, we told you that there's a CAR T therapy that trying to train your immune cells outside your body and put it in. So brain cancer is a very, very tricky cancer because there's a blood-brain barrier that will try to inhibit your immune cells to go in. But lately, based on clinical trial data, CAR T immunotherapy has shown very promising data in pediatric brain cancers, and quite a number of aggressive malignant brain cancer has shown a very good long-term benefit. Okay. So watch out the space, something is going on.
Okay. Hui Ting wants to know, is immunotherapy available in dedicated hospital in Malaysia? What is the effectiveness to breast cancer? So, Suwan, would you like to take that?
I think Prof. Ho is a better person to take that question, but I'll try. I think certainly in triple negative breast cancer, there's an early indication that some patients will respond. Potentially 1 in 5 patients could respond. But in the other types of breast cancer, I think the response has been a lot lower, and it's much less known as about which patients may respond to that. So for now, I think it's only triple negative breast cancer patients. Maybe Prof. Ho would also like to comment on that.
Yeah, and which hospital is dedicated to give that treatment in Malaysia?
Immunotherapy drug is available anywhere as long as you can pay for it. So if you want to get free immunotherapy, then you have to go to a center with clinical trials. For example, oral trial. So if this patient has stage 4 triple negative breast cancer after failing 1 or 2 lines of chemo, then this patient can participate in oral trial. We'll give free pembrolizumab.
Okay, on that basis, the person also want to know how much does immunotherapy cost today, for example, breast cancer?
Pembrolizumab costs 34K per shot, but buy one, get one free.
Buy one, get one free, 34,000 per shot. That sounds quite expensive. Okay, Wai Heng Chu wants to know, mRNA has been effective for COVID-19. How would it play out in the cancer immunotherapy? Thank you very much. Sok Chin, can you answer that?
Sure. I'm really pleased that people are kind of asking about mRNA vaccines because people are very educated in this area at this point. There are actually mRNA vaccines being developed for cancer immunotherapy, but again, this is not in mainstream yet. They are in clinical testing.
Okay.
By the same companies that developed the COVID mRNA vaccines, actually.
Yeah.
Yeah, indeed. Okay. So, Stephen, cost of immunotherapy is expensive. Can drug company allow a lower cost? Early on, we talk about buy one, get one free. So I'm sure a lot of the drug company are trying their best to help, especially countries like Malaysia. Yeah. Okay. Adelina want to know, hi, is there part of the biochemical that can help select patients respond to immunotherapy by Dr. Cheong? Can you elaborate more on why a lot of mutation will be more likely to respond to immunotherapy? Dr. Cheong?
For the part where biomarkers can help select responders to, we talk about biomarkers for immunotherapy, and for certain cancers, for example, MSI high is a marker for prescribing immunotherapy. But as I mentioned, some biomarkers, for example, PD-L1 expression are not universal across all cancer types. Why would there be, okay, when a tumor has a lot of mutations, basically this is what we call new antigen, because it's a mutation, it is not the original form of the protein. So therefore, the immune system can detect it as being abnormal, and therefore the immune system gets hyperactivated because it sees it as being foreign, and therefore the immune system is likely more activated, and therefore patient will be likely to respond to the immunotherapy.
So Wang, do you want to add a little bit to that?
No, I think we have a heck of a lot of questions to go.
Okay. Sandra Gayson said, as a caregiver, my wife keeps harping on food control, especially sugar, meat intake, and cancer recovery, regardless of issues such as stress. Regarding issues such as stress. So please advise. I mean, KP, would you like to answer that?
I think I'm not a nutritionist, but I always think that eating moderately on every single food will be good for your health. So yes, sugar intake is not good, but moderately intake of some sugars would be okay.
Okay, right. Stephen wants to know, is there a test for multiple cancer in early stages as a form of screening? So one, take that.
I wish there was. Unfortunately, there isn't. So there isn't a magic blood test that we can take that will tell us detect all cancers. And there's also no imaging test. You can't do a whole body imaging and attempt to detect cancers. The reality is that we have to be specific for each cancer. And I think the take-home message that we need to be aware of is, for women, be aware of breast cancer, cervical cancer, and colorectal cancer. And there's screening available for these three. And for men, it's really mostly about colorectal cancer. Prostate cancer is a bit on the line. You should talk to urologists, especially people like George. And then I think there's a question mark around lung cancer, whether you should have early detection of lung cancer, particularly among smokers. So I think the take-home message is 3 cancers for men, 3 cancers for women, and don't really think about the screening for the other cancers. Unfortunately, there isn't such a test that's available today.
Yeah, Prof. Ho, next question. What are the early symptoms of skin cancer? Can it be prevented?
Skin cancer is mostly related to sun exposure. So you can't really prevent it, and you don't want to have sunburn when you're a child, or when you go out too much and get sunburn. So prevent that. But there's no early symptoms, so you have to basically just do skin examination.
Okay, all right, okay. Sarah Sham wants to know, is immunotherapy a treatment option for me? Since my small family have 3 persons who has cancer, who are cancer fighters, my mother, my cousin, and also my grandma. So obviously someone's concerned, about, immunotherapy as a form of like prevention, for example. I mean, Sok Ching, do you want to take that?
Yeah, currently, immunotherapy, there isn't any indication for immunotherapy in terms of the prevention at least at this point. For somebody who hasn't got cancer, so I think the answer is no. Shouldn't be giving immunotherapy to this person. Yeah.
Okay, right.
But I think it's worth pointing out that if you have such strong family history, you might want to talk to a genetic counselor to kind of figure out whether, there's a possibility of an inherited gene within the family. Because if there is an identified inherited gene, then you could take on a screening strategy or preventative strategy that's appropriate for the family. So rather than kind of jumping into immunotherapy, which is not evidence-based in a prevention setting, maybe consider talking to a genetic counselor about that.
Great point, great point. Okay, Sarah Sham wants to know, can immunotherapy cure stage 4 cancer? Obviously not very specific, but KP, how do you answer that question?
I think for most of the immunotherapy out there, they are first tested on late-stage cancer who exhausted treatment therapies. So those are stage 3 and 4 patients and achieving response rate between 15 to 30%. So they are patient responded and showing long-term survival benefit.
Yeah, obviously with time that will, become longer, obviously, for survival benefit, right? Okay. Anonymous attendee also want to know, is it worth avoiding carcinogens when there are so many of them? So, Ching, carcinogens, so many of them.
It sounds like a philosophical question. Should we all just like smoke like crazy and drink lots of alcohol and eat all the barbecue meat the way we would like to, and eat ice cream for dinner instead of, a regular diet, right? So, Ching, how are we going to answer this?
I mean, if you know that something is carcinogen, I wouldn't go and do it, I think. I mean, that's my straight answer. But of course, you have to walk out in the sun, which is UV, right? And but we know some ways of protecting ourselves, and I think we really should take those seriously. Yeah.
All right, okay. I think we got one last question from Sander Gesan and said, obviously he suffered from testicular cancer earlier on. How many PET CT scan can you do in a year? Because he's done 4 since 2019 over the last 2 years, and then more in January 2021. Professor Ho, you see this all the time. Obviously, the guideline says that you do CT scan every 4 months, and then the patient is worried about how much radiation can you expose yourself to. How do you answer that?
Actually, it's about the risk and benefit. So, of course, we won't do a PET scan for someone off the street. So, if you have cancer and they're worried about recurrence, then they will do regular scan. How many can you do in a year? There's no limit. So, as required. So, the doctor will advise you. Because in the first 2-3 years, the risk of relapse is higher. So, they need to monitor more frequently. But after that, they will do less and less. So, yeah, follow the doctor's advice.
Yeah. So don't worry, Dr. Lo is watching your back to make sure that you're not really exposed too much to radiation. On that note, I am just wrapping up this really poorly time control. I've got about 1 minute left. Gurpreet, please forgive me. And then I really thoroughly enjoyed myself. That's the reason why I lost track of the time. I learned an awful lot. And then most importantly, we know that a lot of the time, Cancer Research Malaysia is doing great work to make sure that we got brighter future as far as cancer control is concerned.
Not a problem, George. I think you did fantastically well. Thank you. Thank you for moderating the panel discussion and the Q&A that came subsequently. Thank you so much. I think one of the things that I was so perplexed by, on top of all the information that was shared as I was trying to consume it, absorb it, distill it, understand it, one question kind of remained in my mind. I was so perplexed. How is a good-looking man like you celebrating Singles Day? What's going on, George? You're a doctor. If you're Indian like me, you'll be married now and done already. It's all over.
It's all the hard work, it's like Singles Day. It's just like, it's at home. Drown your sorrow with a lot of wine and alcohol. Right?
Well, thank you, George. Always a joy having you here with us. And on a serious note, thank you, panelists, as well, for sharing the wealth of your experience with us for our collective benefit. We really enjoyed hearing from you. You can see at the chat as well, everybody's thanking and saying God bless and so on. So really appreciate all the insight and all the information that you were able to share with us today. And I think, folks, no matter where we are at, right, in different stages, whether we are just tuning in to learn, whether we are cancer patients, wherever we may be in our span or life cycle, I think what was shared today, all the 7 facts really highlight the fact that we need research specifically in Asians. If we don't take care of ourselves as Asians, no one else will. And that's why Cancer Research Malaysia exists. And in order to really come up with these insights, research is important. And here in Cancer Research Malaysia, we really believe as long as research continues, there is hope for cancer patients and there's hope for cancer and their families as well. Just like it takes a whole village to raise a child, it takes an entire community to improve treatment outcomes for patients and for individuals. We all have to play our part. And part of that is linking it back to Bold and Beautiful 4.0, right? Where we're all given an opportunity to really leave our mark on the world, to leave a lasting imprint so that we can all make a difference and contribute towards accelerating cancer research, particularly in Asia. So there's three ways that we all can get involved, right? We can scan the QR code that's actually right now on your screen, donate. It can be 10 ringgit, it can be 50 ringgit, whatever that you can afford, that'll be fantastic. Donate to this cause because it's really going to help accelerate cancer research, help cancer patients and their families, particularly when we think about Sarawak Children Cancer Society. They help children that have cancer, as well as their family, counsel them and help them go through that difficult time, as well as you can also shave your head if you like, right? It's just part of expressing solidarity to cancer patients and just the tough and rough journey that they go through, even expressing or coming alongside them to know and recognize the amount of courage that it takes to go through that journey and walk with them side by side to say, okay, we understand, we might not understand it fully, but we still want to express that you matter and your life matters and we're going to do this together. Or you can do both. You can donate, you can shave your head. There's multiple ways that we can do this together. But before we bring things to a close, I just wanted to play a short video that highlights the importance of cancer research in Asia. So let's tune to this 1.5 minute video and then we'll bring things to a close here.
Did you know?
Did you know? Did you know?
Did you know?
Did you know?
Did you know that cures for some cancers do exist?
There are over 200 different types of cancers.
And some of them are already curable.
You could say that researchers have found a way to reverse cancer.
But it didn't happen overnight.
I survived cancer.
I survived cancer.
I survived cancer.
I survived cancer because of medical research
done yesterday.
I believe
to cure more types of cancers tomorrow.
We need to do more research today.
Today.
We are Cancer Research Malaysia,
A non-profit medical research organization
working to reverse cancer
in as many ways as we can.
In the world of cancer research, there isn't enough.
There really isn't enough focus on Asian genetics
and the cancers that are common here.
We are ensuring that the fight against cancer
doesn't miss Asians,
especially Malaysians.
Like you and me.
Like you and me.
But we need your support.
We need your support.
We need your support.
Because we are funded entirely by donations.
We are already working on vaccines to prevent some cancers.
Our scientists are using genetics to sharpen diagnosis
and therapy.
New ways to make treatment more accessible to patients.
Projects to reuse existing drugs in new and more affordable ways.
Mobile technology to speed up screening
in remote locations.
We have started this fight.
But there's so much more we can do.
Talk to us
and find out how science can reverse cancer for our future
and the future of our loved ones.
And please donate to ensure we finish this fight.
We are Cancer Research Malaysia.
And we are reversing cancer
through research.
All right, remember, ladies and gentlemen, we all have the opportunity to do good and leave our mark on the world. Support Bold and Beautiful 4.0 and let's make a difference together. That's all from us today. We hope that you've been encouraged and found our time together here insightful and useful. Let's play our part. Until next time, have a pleasant evening and goodbye. Thank you for joining us once again.
You're here, you're loved, you are light. Rewrite your future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. It's just the darkest, just right before the dawn. Then it's a new day, your chance to take a breath. There's been pain, there's been tears when you said that you can't go on. But have faith and embrace. Now the sun has come. Let it shine and show your path. You're here, you're loved, you are alive. You're not your past, who you are is much stronger than that. But if you fall, you get up and fight with your mind. You're here, you're loved, you are alive. Rewrite your future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. A brand new spirit, the time has come to soar. That's strength within you, no one can tear it apart. Wipe your tears, don't forget those scars prove you have been through all. So stand tall, spread your wings. You have braved through your pain. Now let your courage take flight. You're here, you're loved, you are alive. You're not your past, who you are is much stronger than that. But if you fall, you get up, fight with all your might. You're here, you're loved, you are alive. Rewrite your future, you know that the phoenix will rise. I'm by your side. Everything's gonna be alright. I'm here, I'm loved, I am light. I'm not my past, who I am is much stronger than that. But if I